Hi everyone, this is Babaiah, Assistant Professor of EC Department, MLR IT, Hyderabad. Today I am going to explain or derive the sum problems based on the RH criterion method. Previously we learned some problems on RH criterion method. The first normal array we are seen on that class. Now today we are going to see the remaining cases. In that the second case comes here. Uh, in first element of row is 0. That is the case or a special case of the RH criterion method. In that case we are going to solve the some one problem. Here see, the first element of a row is 0. In that, use this row criterion or stability criterion. We are going to consider this characteristic equation. The given characteristic equation is s power of 5 plus 4 s power of 4 plus 8s cube plus 8s square plus 7s plus 4 equals to 0. Now we are going to calculate or solve the problem by using the RH criterion method. The case is first element of a row is 0. Now see, when it is comes to first row is 0, see, observe here from the given question, just to observe, this is our characteristic equation, right? So from that we are going to arrange the array matrix. Here what is the maximum power of the S is nothing but here 5. So this is nothing but the order. So that is order is nothing but the characteristic equation roots are nothing but the order here. So maximum power of S, that is the 5. So fifth order characteristic equation. So that's why this is nothing but the roots of the characteristic equation. Simply for the given characteristic equation we have a 5 roots. So here now we are going to arrange the array matrix. See, s power of 5 and s power of 4, s cube, s square, s power of 1 and s power of 0. See here, s power of 5, it is the odd power. So s power of 5 is the odd number. So odd number of coefficient, first one is 1. Next odd number is s cube, so that is 8. Next s power of 1, 7, and here there is a no s term. So here s power of 5, 3 and 1. Next s power of 4, the coefficient of that is even power. So even power, consider here 4, and here s square 8, and s power of 0 is 4. This is the array matrix. See here 4, 8, 4. Now we are going to easy to calculate this. For we are going to divide the 4 by 4. It is going to be what, 1. So divided by 4, that is equals to 1. Here by 4, that is equals to 2. Here divided by 4, that is equals to 1. It is for the easy for calculations. If you want to do the division for the number 4 or else leave directly, you should solve by using the 4, 8, 4 also, no problem, right? So 187 and 1, 2, 1. Now see here 187, 1 and 1, this term s cube, 1 and 8, and here also 1 and 2, 1 and 2. So here 1 and 8, so directly I am going to write here 1 and 8, 8 minus, and 1 and 2 is 2, divided by here term 1. Here 1 is our base. So here 1, 8 minus 2 is nothing but the 6 by 1, right? Here 6, this term. Okay, next here see 1 and 7, 7 minus, and 1 and 2, or else this is the one more method, and also by without division of this 4 directly solve here, or else here see 7, 1 into 7 is 7 minus, and 1 and 4, oh sorry, 1 and 1, so 1 divided by, so our base is 1, so 1 and 7 and 1 and 1 divided by 1, that is 6. Here we got the 6, and here also 6. Last term is 0. There is a no terms after that. So that's why 6, 6, 0. So now s square terms. S square row for that calculation. 6 into 2, here 2 is there, and 1 into 6. 6 into 2 minus 1 into 6 divided by 6. So 12 minus 6 is 6. 6 divided by 6, that is equals to 1. So here 1. Next here 6 and 2. Sorry, 6 and 1. 6 minus 1 and 0 is 0 divided by 6, that is equals to 1 only. So here also 1. So 1 1 and 0. Next s power of 1. So 1 and 6. 1 and 6. 6 minus 6 is 0. This term is 0. Next 1 minus 1 and 0 is 0, and 6 and 0 and 0. So 1 0 0 and 6. 1 6 6 minus 6 divided by 1, that is 0. Here 1 and 0 minus 6 into 0, 0 by something is here 0. So next term also we are going to get the 0, s power of 5, and next 0 0. So completely row is going to be 0. See here, observe one more time, or otherwise I am going to see this one here. And next slide, just to see s power of 5 and s power of 4, s cube and s square. Okay, so coefficient is here, total is, order is 5. So order 5. So 5 roots. So 1, 8, 8 and 7. Here 4, 8 and 4. 4, 8 and 4. So divide by 4 is 1, 2 and 1. So 1 and 8, 8 minus 2 divided by 1. So 6. Here 1 into 7 minus 1 divided by 1. So 6. So here 6 and 6 0. Okay. So that's it. So element is going to be 0. So this is the how to design the RH criterion or array matrix. So this procedure we need to follow. Next we are going to solve this condition. Element is 0 or both elements are, if this one here also 0, if we are going to get the zeros in this condition, first element 0 or else row, complete row, any row 0. That is two conditions. So first element 0 or any row. If now this all complete one row going to be 0 condition. So this is to arrange the array matrix. For that we are going to use some special cases. Next we are going to see that special cases, how to solve in this condition. We are going to assume the auxiliary calculation, and also in first element 0 condition we are going to assume the epsilon. So for that we are going to solve the complete problem by assuming the epsilon in condition of first element of row is 0 and the row, complete row is going to be 0. In that condition we are going to assume the or consider the auxiliary polynomial equation. Auxiliary polynomial equation is nothing but what? The 0th row above row is nothing but the auxiliary polynomial equation. Always auxiliary polynomial equation is the even powers only. We need to consider the auxiliary polynomial equation. From that we are going to solve the characteristics or roots of that polynomial equation. Then finally we are going to observe the complete one single column. Any rows are going to be any row elements are positive or negative or any changes are there, we are going to observe in that. After that, finally we are going to say the given system is stable system or unstable system or marginally stable system. If complete row is going to be 0 condition, most of that system is going to be marginally stable or conditionally stable systems. It is the condition of or based on the row elements. Any row elements are going to be 0. In that condition, we are going to say simply. Or in a epsilon condition is first element of any row is going to be 0. So that is the procedure to solve the two cases. We are going to assume the epsilon and auxiliary polynomial equation. The two conditions we are going to see the one problem. Then next I am going to explain the two in detail. Okay, thank you all. I hope you understood this, how to arrange the given matrix, and that is comes under the first element is 0 or else complete row is 0 or normal row. We observe that array matrix. After that, we are going to solve that problem by assuming the epsilon for the first element of row is 0, and also we are going to assume the auxiliary polynomial or consider the auxiliary polynomial equation of the complete row elements above row, and or else normal row. Just observe the first column elements, any sign changes are there. Based on these three conditions, we are going to say the given system is stable system or unstable system or marginally stable system. This is about the how to design the array matrix and how to categorize the given array matrix into the special cases. Next, we are going to solve that. Based on that special cases, we are going to solve the some problems. Okay, thank you all.